Hi class, we are moving on to topic 2. So this is our second 8th grade standard. We're going to work with solving equations with variables on both sides. Now I know I've shown you this a lot and I've asked you to do this on multiple math boxes earlier in the year. So you basically have already done this, but we're really going to get into it and practice it. And I know like when we did math boxes, I said, oh, these are challenging ones, try them out, and we kind of went over them. Well, now you're expected to learn and know how to do it. So we'll get into it a little deeper. So to solve equations with variables on both sides, we have to collect all of our variable terms, put them on one side, and then collect all your constant terms and put them on the other side. Doesn't matter which side you decide to put your variables, on the left or the right, just whatever you choose, you then want to put your constants on the other side. So we're just kind of manipulating the terms and getting them to different sides so we can combine our like terms. So let's look at this first example here, solving an equation with variables on both sides. So I noticed I have 15 minus 2x equals negative 7x. I have negative 2x and negative 7x on opposite sides of the equal sign, but I want them to be on the same side. So what I decided to do is I decided to get that negative 2x away from that constant. So to get rid of negative 2x, I'm going to add 2x to both sides. When I did that, my negative 2 and positive 2x canceled. And then now I did negative 7x and negative 2x, a positive 2x to give me a negative 5x. So then I have 15 on the left, so that's my constant terms, and then I have my variable terms on the right. Now we're just continuing to solve for x. So I'm dividing by negative 5 on both sides to get negative 3 for x. Let's keep moving here. Let's look at our next example. I also did this one. I want to walk you through it. Take a look at my work as I talk you through it and see if you can understand. So first what I notice is that this is a multiple step problem. I first need to distribute. Remember, whenever you see the distributive property, do that first. So I distributed that negative 2 and I got negative 2x plus 10. That's how I got what I have on the left side. Remember, a negative and a negative, when I had that negative 2 and that negative 5, it gives me a positive 10. Now on the right, distribute that 6. 6 times 2 is 12, and then 6 times a half, so half of 6 is 3x. Positive times a negative gives me a negative 3x. Now, notice, I have negative 2x on the left, and I have a negative 3x on the right. So I have variables on both sides, as well as having constants on both sides. I have this plus 10 and this positive 12. They're both on separate sides. So I want to move my constants together and my variables together. First, what I decided to do was move that negative 3x from the right side. So I decided to add 3x to both sides to get that over with that negative 2x. So negative 2x and a positive 3x just gives me x. I still have plus 10, and then I only have a 12 left now on the right side. So this now was my new equation, and now I'm just solving that. Now I'm moving that constant over to the right side. So to get rid of plus 10, I subtracted 10 from both sides. That canceled. And then 12 minus 10 gives me 2. So x equals 2. Remember, if you ever want to check, like example 1 and 2, I could have checked my solution. Do a check, plug in what you got, and see if you are correct. All right, your turn. What I would like you to do is pause this video, write down this equation right here, and then when you're ready to go, once you've solved it, you may press play and we'll solve it together. All right, welcome back. Let's work through this problem together. Let's see how well you did. So first thing I notice, I want to do the distributive property. I'm going to distribute this 6 to both terms. So I get 24 minus 6z equals 2z. Now I notice there's a z on the left side and a z on the right side. I want to get that negative 6z away from the constant. Because remember, we want our constants on one side and our variables on the other. So I'm going to add 6z to both sides. When I do that, I get 8z, and I still have 24 on the left. Now we're just simply solving for z. Divide by 8. 24 divided by 8 gives me z to equal 3. If you got 3, good job. Real quick, I actually want to go through a check. If you remember how to do a check, maybe you want to fast forward. I wouldn't mind. But a check real quick. Remember, we're replacing z with 3 from your original. So I'm going to plug that in. And now I'm going to evaluate. 4 minus 3 gives me 1. 1 times 6 gives me 6. 2 times 3 is 6. Is this true? Does 6 equal 6? Yes. So my check is correct. And I know that I'm correct. All right, let's keep moving here. So that was our first page for topic 2. Now let's go on to our second page. This is where we're getting into something new as well. We're going to talk about what happens when you're solving an equation and there is no solution. So that can happen sometimes. So solving equations with no solution, what does that mean? So some equations do not have one solution. Equations can have no solution, or they can have infinitely many solutions. So when solving an equation that has no solution, you will obtain an equation where it's not true. So you'll come down to a point where it'll say 0 equals 2, for example, but that's not true. 0 does not, in fact, equal 2. So you would say that there is no solution to this equation. So let's try an example together. We want to solve this equation right here. Let me actually highlight that. So first thing I want to do, get all your equations, all your constants on one side and all your variables on the other side. So first, I'm going to add 4x. I'm going to get it away from this 3. But if I notice, a negative 4x and a positive 4x, they cancel as well. So I'm left with 3 equals negative 7. Does 3 in fact equal negative 7? No, that's not true. So since it is not true, that means that this equation has no solution. So that would be your final answer. We can't figure out what x equals. So instead, we're just going to state that there is no solution. And that's going to happen sometimes for you. Well, what happens when there's infinitely many solutions? That means when you're solving an equation, you're going to obtain something that actually is in fact true. It is equal to each other. So it's a true for all values of the variable. So you're going to get something that might look like negative 5 equals negative 5. Well, yeah, that is true. Negative 5 does equal negative 5. So what that means is that any value we want x to be, it can be. There's infinite solutions. X could be 1, 2, 3. It could be any number you want, because no matter what x is, the statement is still going to remain true. So let's solve this equation together. Let me highlight it here. First thing I noticed that we should do is distribute this 4 to each term. So when I do 4 times 1.5, I get 6. So I have 6x. 4 times 1 gives me 4. And let me still bring down what I had on the left side. Now guys, you might be able to notice right here automatically, 6x plus 4, that's the same expression. That's equal to 6x plus 4. They're equal to each other. But let's continue to solve it for solving sake. So I'm going to subtract 6x. And again, you can move these in whatever way you want. But when I take 6 away from 6x, I get 0 on both sides. So all I'm left with is 4 equals 4. Is that in fact true? Does 4 equal 4? Well, yeah, that's true. So since we came down to that, right, our variables all canceled out, we're just left with constants, and those constants are true, then we would say that this has infinite solutions, or infinitely many solutions. So there are infinite solutions to this equation. X could be anything you want. No matter what I plug in for X, like if I'm looking back at this original maybe here, the second step, whatever I want X to be, if I plug that in, it's going to remain true. So there are infinite solutions here. All right, now is your time. What I would like you to do is do me a favor, pause the video and solve both of these equations based off of what we just reviewed. Once you solved them, go ahead and press play and we'll go over them. All right, welcome back. Let's get through these examples real quick. My first one to the left here, I'm going to get my constants together and my variables together. So first thing I want to do, I might want to subtract 2x from each side. That's just going to cancel. I have 1 equals -1. All I'm left with are those constants. Does 1 equal -1? Well, no, that's not true. So that means this would have no solution. Let's look to the right. Let's try this other example out. First thing I noticed that we should do is distribute. We actually have to distribute on both sides. 6 times 5 is 30. 6 times -2v gives me -12v. -4 times +3v gives me -12v. -4 times +1 gives me -4. Now let's combine our like terms or move some things around. I'm going to move this, I'm going to move this -12v over to the left by adding 12v. Negative and a positive, again, they cancel. So this all cancels. I'm only left with my constants now, which are 30 and -4. Does 30 equal -4? No, that's not true. So this one again is no solution. There's no number, there's no value that X could be or V or in either of these situations where they would be equivalent to each other. So in fact, there's no solution for either of these. All right, hopefully you got those two correct. If not, by me going over it, you understand now the difference between having no solution, infinite solutions, or like we did on the first few examples, your equation could have just one solution.